Again, I am live for some more of Odinmade Hero, where I try my best to keep up with Casey on Handmade Hero. It's like the Handmade Hero challenge. I'm like challenging myself to do, I don't know about the whole series, but as much of it as I feel is necessary to get competent one day at a time, get more competent at games programming. And yesterday was kind of a mixed bag. I wound up working through the rest of the code for day 35. So now we're on day 36, or we're about to start day 36. But yesterday was mostly about getting some sparse tile map storage going for this little rectangle game we've got going on so far. And so the rest of the code yesterday, after getting the sparse storage working, all that I did was follow Casey through to the end of the day to get, this kind of room, this very dumb procedural room generation going. So now I'm stuck in this room, and there's a staircase right here. That's what this dark gray square is. So I can't go into it, and we might actually be working on implementing the staircases or ladders, whatever we're going to call them, today. But the idea is that now we're storing the tile map in Z. So instead of it just being one long game world on one plane that is two-dimensional, we can actually go up and down in 3D space in the 2D game world, if that makes sense. So I can't remember if this door goes up or down. I think this or not this door, but this staircase, right? I think it's supposed to go up, but I can disable my staircases if I jump into the code here. And if I just say over here, so what this code does is says, hey, if we already had a door up or a door down, we need to make a door going out of the next room. So we're not just going up and down in the same room over and over. So if I disable that by saying we already had a door up or down, or a staircase up or down, now I get back into my nice big long tile map that just goes from room to room all the way to the end, which is however many different rooms we're specifying. Which over here, like if I change this number right to 10, then we'd only have 10 tile map rooms. Likewise, if I only changed it to 1, I don't even know if this will work the way I think it will. I think it does. We'll get one room. So we get one room, and it just dumps us out into the rest of the world that we've generated, which is just this one tile chunk. So kind of need to just play around with that stuff and see, test my understanding of what it is I've done thus far. But yeah, so this code wasn't too exciting, and it was a little bit confusing. I confused myself yet again, trying to get caught up to day 36. But yeah, yesterday I just got hung up on this detail. I noticed that Casey had changed the chunk shift value, as well as the X and Y amount of tiles, or rather the number of chunks going across and down the whole tile map, right? And so I missed this part, and it was because he had made these changes actually on the day prior, on day 34. So I thought I had missed something, and I was like, what is going on here? How did I miss him do that? It was at the very end of the previous day, right in between, right when he was about to go into the Q&A, so I missed that, which was sad. So with all that being said, I think we can just jump on in. I am pretty sure I'm not going to be able to wrap up today's coding either. It looks like Casey kind of changed his camera format here. But yeah, today I doubt I'm going to be able to wrap this day up either, so we'll see if I have to split it up and finish it up tomorrow. But we're just going to be loading some of the art that he had made for the early days of Handmade Hero, and so I'm gonna have to dig through and dig up that art, which, if you were so inclined, you could actually go and pay for the assets and all the code yourself and get it yourself. But I already have done that, so I already have the art, so I can just drop it in the same way he's doing it. So let's get going.
Here we go. Hello everyone, and welcome to Handmade Hero, the show where we code a complete game from scratch using nothing but our barest typing fingers, no libraries, no engine, just so we can see basically everything that goes into a game's execution, every last thing. And we're basically trying to make sure that we understand everything that a computer does when running a game. And at this point in the process, we're actually fairly far along. We've made a Win32 prototyping layer. We've made a tile map storage system for ourselves. And we're starting to kind of, we're trying to basically figure out what our engine architecture should be like so that we can start to write the engine proper that will run our entire game. And so one of the things that I push a lot in terms of good programming practices that I think everyone should do is always experiment and explore first before you design. It's always a good idea to kind of let designs come out of an exploration rather than trying to force them by doing design up front without really knowing what you're getting into and then trying to follow the design and finding out that it's not so good. And so that's really the process that we're going through right now. We did that, and we sort of came to a place where we were pretty happy with our tile map system, which is just one aspect of how we need to design the engine. And so now we're kind of looking at just kind of wrapping that up a little bit and then moving into some other things that we need to do. There's a bunch of other stuff, obviously, besides the tile map that go into making a game, and so we have to kind of start thinking about what those are. Now, if you have pre-ordered the game, and there's a little bit more to talk about today regarding this, if you have pre-ordered the game on handmadehero.org using the pre-order button, you will have gotten an email with, obviously you get access to all the source code, but you also get access to all of the art assets that we use during development. And so one of the things I want to point out is, normally I say at this part of the stream, go to the link that's in that email and make sure that you download the right source code to start with from today if you want to follow along. And today is day 36, so you want to unzip day 35 source code. But for the first time today also, if you look on that link, when you go to that link, you basically get presented with a bunch of things that you can download that will kind of increase over time as we add more things to the distribution. Instead of just the source code now, you will also see a link to download the test assets. And basically, these won't change very frequently. Like, we'll only update the test assets every once in a while, but since this is the first time, everyone has to go and get the test assets for sure. Basically, what they are is they're just a zip file that has in them one directory called test. And what I want you to do is I want you to go ahead and put that into our handmade directory. So basically, here's our source directory, right? We have our code, we have our data, we have our MISC, and so on. I gotta remember to turn off arrow shake. Someone sent me how to do it, but I forget how to do it. But basically, inside...
So he's already on top of this, but that's what I was doing in the background here, just getting all of these different assets copied into my project, which I already had on my machine for my Zig project, but now we've got them in our Odin project, so good to go.
This data directory, what I want you to do is basically go into that data directory, and we're just going to drag the test executable, the test directory right in there. And so then if you look inside there now, we basically have a bunch of bitmaps that I've prepared for us, which just have, they're very simple files that just have some stuff that we're going to use to experiment with. And you can kind of see if you click on them, we just got some stuff. None of these are final assets for the game or anything, but they're basically like pieces of a character and a shadow that we can use. There's some layers for basically like for a scene that we're going to test with. And for some reason, and I don't really know what the reason is, Windows doesn't display bitmaps properly. I'm not sure if you've noticed this, but like basically, like if you have a bitmap, a BMP file that has like, I'm trying to think of, I'll load one of them here. If you have a BMP that actually has transparency in it, like it tends to go wonky on me. Like you can see this has transparency here, right? Like or something like that. Or what was the one that just looked really weird? So like this looks really weird. Test scene layer 01. So test scene layer 01, if I open that up with GIMP, I believe that it looks correct, right? Yeah, you can kind of see that it looks correct. There's a transparent region. All the colors look roughly like they do, right? And this is the background from like the website and stuff. But for some reason, if you look at them in the Windows photo viewer, like Windows couldn't manage to load a BMP. Now this is amusing because, well, I mean, Windows, they're the people who invented the BMP file format. So somehow they don't know how to read their own file format. What are you going to do? That's just, that's life in Windows, ladies and gentlemen. Sometimes you don't know how to read your own file format, I guess. Anyway, basically, what we're going to be doing possibly later today, if not tomorrow, depending on where we get to, is we're going to be starting to use these assets. I'm going to show you how to load them in, and I'm going to show you how to use them, on the screen and stuff, just to get things started, because I wanted to have, for us to be able to start looking at the scale of things and how things looked on the screen. And so we're going to have to write, probably not really the renderer yet, because that's like a huge involved process that we'll start on and do many days worth of like explaining how renderers work and how all the math works and how we want to approach them and so on. But we're going to write basically some very simple little system that can just load bitmaps and put them up on the screen, so that we, as we sort of move forward with our engine architecture, we won't be flying blind, because rectangles can get us a certain, can get us only so far basically in terms of making good decisions about how things are supposed to work. So please make sure that if you're trying to follow along at home that you go ahead and do that. Hopefully you've already done it. Should be pretty simple. Again, just go to that link, download Handmade Hero test assets 001.zip, and I will notify you guys anytime that you need to download a new one. But like I said, they should be pretty infrequent, because basically I'll batch up a bunch of new assets that when I know we're working on something in particular and I know we're going to need the assets, I'll batch them up. So we shouldn't need, you shouldn't need to update this hardly at all. It should be very infrequent. But once in a while you will have to do it as we start using different assets, types, and stuff like that. All right. So that's basically the situation that we're in. So now that we've got that going, let's go back.
Before he goes any further, I just heard a loud banging sound coming from inside the house, so I'm going to make sure that the family is okay. I have no idea what that was, but everybody looks fine.
to where we were on Friday because we had a couple loose ends, if I remember correctly, that we need to tie off, namely just walking up and down through doors. So basically, up and down through like stairwells, basically. If I remember correctly, what we sort of said is, okay, we basically wanted to have two planes of our tile map system, one like sort of an upper and a lower plane that we tried to make, and we have like this concept of a door, but we, a stairwell like in between them. One that we have a tile that goes you up a level and a tile that goes down a level, but we don't actually have any code to handle what happens when you actually move on to one, right? So basically, when you move on to one of these, we need to have some way that allows you to kind of change up and down. And again, this was not to do anything specific. It was just to make sure that we could have our tile map system working with two different planes so that, we can have basically a Z component. And once we handle this Z component properly, we did it in a generic way, so it should be able to handle as many planes as we want. We can have as many layers like stacked on top of each other as we want to have. Okay, so basically what we need to do is we need to make some changes to the player code. And since we don't really have real player code yet, since we haven't really addressed that, it's going to be a little harder than it should be because basically all we've got is a thing that just kind of like checks to see where the player is going to be and then moves them, right? This is the player code that we have. We basically create a new player position. We check to see whether the player can move wherever it's going to be, and then we kind of have this sort of acceptance function, which basically says, okay, accept the new location. And so what we kind of want to do here is if the player moves onto this tile, we want to do an action at the time when they move onto it, right? That's basically what we're trying to do. We're trying to do something that basically says, if they moved onto a new tile, meaning basically if the new player P tile index is not the same as the old player P tile index, then we want to do something. So basically what I'm going to do is I'm just going to introduce a function here that I can call basically just something I basically want a predicate. I want to be able to say, tile are on same tile or something like that. I just want to be able to make that statement. I want to ask that question and say if they weren't on the same tile, then what I want to do is just take an action. I want to look to see what this is. And now when we do more player movement code, we'll actually have a lot more formalized ways of doing this and what happens when someone moves onto a tile. But for now, I'm just going to go ahead and check for the two things that we set up. Again, we just had sort of, this is all total scratch code to see how things work, but we basically said that door ups were 3, door downs were 4. So I'm just going to check for those. And again, because this code is all getting nuked for much more, for different code later, I'm not actually being specific about these things. I don't care about pound defining them to real things or making enumerates or anything like that because we're not going to be doing anything like this in the final code. This is just sort of glue code that allows us to test other systems, and then later when it comes time to actually focus on it, it will all get blown away and we'll kind of move forward. Same with like that, our level generation code is all exactly that. It's just total crap code that's just there to sort of glue things together and let us move forward with our experimentation. And the reason again that I don't try to do a good job on that kind of code, I only do the bare minimum, is because I just don't want to waste a lot of time thinking about how that code should work at the wrong time. I would say one thing that's worth mentioning is there is a context switch cost oftentimes in coding where if you're working on one thing and you go switch to working on another thing, there is a cost in terms of your brain and how like sort of ready it is and how much stuff it's got paged in, almost like a virtual memory system, right, for the particular problem that you're working on. And so one thing that I'd like to do is when I'm concentrating on one thing, I like to try and just keep concentrating on that one thing, even if that means me putting bad code in some other place. As long as I know that the bad code is there and I'm aware that that's the code that needs to not be there eventually, I'm okay with that. Because basically I want to focus on the thing I'm focusing on and get as much utility out of my brain's sort of focus on that part as I can. And so I don't want to spend a lot of time doing things like thinking about how to specify tile values because I know later we're going to spend a whole bunch of time thinking about how we specify tile values. So any time we spend now is really just kind of wasted.
It's not that he's not wrong, but there is certainly a caveat to that where it's like if you put that bad code in there and then you come back to it after a long time and you look at it and you're trying to make sense of it and you realize, oh, this is terrible code that I wrote thinking it was going to be temporary and it just wound up sticking around all this time and now I spent all this time trying to figure out what it was that I was intending to do. It's very, but what he was just speaking to, that idea of like paging the problem space in and out of your head and context switching from thing to thing is like, it is the biggest source of frustration for me where I want to have all the context in my entire head at all times. And you obviously just can't do that indefinitely. There's a limit to what your brain can work with. And, I just feel like I'm working with a very small page size sometimes.
So that said, what I want to do is I want to get the tile map value at this point that the player is at when I determine that they move to a new location, right? So this new player P, wherever they are, I'm going to go ahead and sort of grab what the tile value is there. So basically I'm going to go to our tile map functions that we have. If you remember, we pulled them out into this separate file here. And I'm basically going to just ask what that tile value is. So I'm going to basically try to, let's see where it is, get tile value right here. And I'm going to want to get that tile value. Now, one of the things we probably want to do, we're probably going to want a function that gets the tile value directly from a player position, because why not? And so I'm probably going to introduce a tile value call that's just basically a proxy call to our other call, which will do that sort of cracking for us. It takes the player position and breaks it out into the smaller values. So basically, we have a tile map. And I'm just going to pass that new player P, and I'm going to say, give me what the tile value is at that location. So this is like the new tile value. And then I'm going to say, all right, if
I don't think we have a get tile proc that looks like that. If I get like tile, what does it get? Chunk tile? Or does it get world tile? Get tile value. Now, once again, the name's not lining up is screwing me over a bit, but let's just presume that we have this get tile value proc for now. I can rename it to the thing it's supposed to be when I get that far.
The new tile value equals, what did we say? That it was 3 and a 4, I believe, is what we said. So if the new tile value is a 3, then we are going to go a door up. So a 3 is a door up, which means that our new player P is technically going to become a whatever their abs tile Z was is going to go up 1, right? This. And if it is if the new tile value is a 4, then they are going to go down 1, right? That's all I want to do there. And then we'll accept the player position. Now, what we could also do here, we could actually treat this as another check move. We could verify that the tile on the other side was empty. But at the moment, like I said, I don't really think we want to deal with that kind of stuff because it's really not important. That's going to be something we have to think about more when we get to later stages of things. For now, we know we always place doors up and doors down symmetrically, so it's fine. So is tile map point empty, we also have to modify, because at the moment is tile map empty was only basically allowed to return true if the tile chunk value is 1. But really what we're allowing it to do now is sort of say there's a bunch of things that sort of classify as empty, if you will, right? There's 3s and 4s are now also considered empty, right? So we need to kind of say, oh, you can move on to something that's a 1, 3, or a 4. And so we'll just go ahead and do that. And that way these checks won't fail when the player tries to move on to a door. And then similarly, the get tile value function, like I said before, I want to be...
Okay, so all this is doing is saying, hey, we want to say that wherever there's a door up, if I can do that properly, or a door down, then that also counts as empty, or at least it's empty space. It's a tile that the player can move on to.
Be able to pass a tile map position to that as well. So we'll go ahead and do that here. And that is just going to...
Okay, so he's just modifying that call altogether. Where did that go? So get world tile. No, that's not right. Where is this proc for me? Okay, so he just has this errant empty up there. I was looking for a proc that opens with this empty variable that he assigns like as a result value, but I think that's just like a leftover that he had. So wherever we're returning a result that is, yeah, I think it's just this right here. It is get world tile. But instead of it taking all of these values separately, we can just bundle them up into a tile map position. And that's the change we're committing to now, which I do like better. Whoa, that is not what I meant to do. Pose, right? And that means that that's going to change to that. Going to get all those values off of that. And now that this code is super wide, we'll break that up. We'll just do it for every proc in here since this one already is and this one is. There we go. Condense that down a little bit. And so in here, that means we just pass in that. Whoops. And that looks good now. Was there anybody else that calls this anywhere? Part of me just wants to change this to get tile value, so I am no longer confusing myself. I think that's just the way to go. Make it easier to move the code into the place that it needs to be in. Get tile value. And I think same thing for set tile value. Why not? I think that one's, I've got that mapping easier in my head, but in the interest of preparing myself to change that again at any point in time, just keep things as consistent as we can. And I think we'll do the same thing here eventually. We don't want to be, or at least this will be a vector that we pass in for setting the tile value. World, get world tile. So this is now get tile value. And we got too many arguments because this should be... Well, I wonder if he's... Yeah, he actually just duplicated it. And I did not notice that. So... Yeah. That is what he... I definitely missed him doing that just now, didn't I? Yeah. So he duplicated it and overloaded this. But I wonder if it just makes sense to say, like... Tile pose. Like, let's just have one proc that does this instead of two. And we can say this is a tile map position. And what is all involved with that? We can leave tile rel X and Y as 0 because we don't want to use them. And then we can just pass in X, Y, and Z. Expected 5 and got 3. Well, I was hoping that it would just know to default the rest of them to 0, but I think I must have to do this and name them. Yeah, now it knows. My trailing comma, no. Trailing comma strikes again. So there we go. Now we just got to declare that R on same tile, which I don't feel great about that name, but again, we've seen what happens to me when I stray too far off the Casey path.
To that as well. So we'll go ahead and do that here. And that is just going to call get tile value. It's really just a pass-through that's going to call, excuse me, that get tile value function for the poses component. So that's just, it's really just a utility. It's so that I don't have to type that if it's something that I'm going to call fairly frequently, which I suspect that it is. I'm just going to go ahead and do that, right? Oh, why is there still an empty there? I got mixed up there. This is actually the return value. That's just lazy code that's around. It is a bit hard for me. Like I've said many times, programming on the stream is a little bit tough sometimes because...
I see. So he wraps it. It accomplishes the same thing, though, right? Like he's wrapping this overloaded get tile value procedure that just calls the one that explicitly passes in the X, Y, and Z for the absolute tile. So I think this is fine. I don't like what would I even call, like maybe it would make sense if I wanted to keep it as close to the way he's doing it. I could call this like, I call the nested one the wrapped, get tile value wrapped proc, but I just don't see the point.
Basically, like it's harder for me to focus when I have to talk, and so code kind of gets a little strange. It's weird. I can't explain the feeling. It's just it's like a little hazy. It's a lot hazier than I am when I'm normally programming, so it's tough. It's definitely like running a marathon with the weight belt on. Anyway, let's see here. So R on same tile now we have to implement. We did not implement that before, so I'm going to go ahead and put that in here. I don't know. Eventually, I feel like we probably want to put stuff like, you know, recanonicalize position and stuff like that. Now that I think about it, like these things really don't have anything to do with well, I guess they do have something to do with the tile map because they involve the tile map locations and the tile side in meters. Of course, the tile side in meters isn't really related as much to the tile map. Blah 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 blah. I could see moving. Basically, I guess here's what I'd say. There's stuff in here that really doesn't have anything to do with the tile map. And I think I might kind of want those things to be cabbed off at some point. Like, these things really are about tile map positioning, and they have nothing to do with the actual tile map. Like, insofar as they care about the tile map, all they really care about is how big a tile is. And that really has nothing to do with the tile map storage, right? And so I'm going to kind of mark these here. I'm just going to say,
I get caught up with him because I was just trying to make sure we were going in the direction I thought we were going in with implementing that R on same tile. Actually, I didn't mean to yank these. I wanted to delete and yank, and I think that's right. So we're gonna throw those down at the bottom, and we're going to create a big old to-do up here to do the thing.
These really belong in more of a positioning or a geometry file, right? Like, and sort of just think about that, because I feel like that's probably going to be the case, that they're inappropriately part of this tile map and they don't really need to be there. So anyway, we now can go back here and say, well, we've got these two tile map positions, right? I've got a tile map position A and a tile map position B, And I want to know, like I said, when they are on the same tile, I want to know whether or not their tile differs or not. Now, it's going to ignore basically these two things, right? And so whether or not the tile differs is really trivial. If they're on the same tile, then all of their tile indice portions will be the same, right? Each individual one of these, oops, that should be an and, each individual one of their components should be exactly the same. Otherwise, they are on a different tile, like that. And then we'll return that result. There we go.
That is pretty straightforward, thankfully. Got a Y here, a Z here. Why can't I replace that with a Z? Thank you. Get stuck in some weird command. Oh, this has to return a bool. Some weird NeoVim command. It happens all the time that I don't mean to be stuck in, and then I try to do the thing 3 times before I'm like, okay, I'm definitely in some weird. I'm like trying to insert something. I don't like some command. I just get into that mode, you know, where I typed an errant colon or hit some key on the keyboard somewhere that did something that like I don't even understand what it's doing. Someday I'll make time to just learn all the things so I know. And also I just need to get better at typing. That's what it comes down to. Don't type the key that you don't mean to type.
And so then I'll go ahead and compile that. Let's take a look. Right, these need to be addresses of these fellows here.
What am I doing wrong here? Oh, it's because I have those trailing ampersands. Don't need those. Nice.
And there we go. So I believe now we should be able to walk onto this. And hey, look, it worked. We went up a level. We can go back down a level again, right? So when we move on there, we go back up a level, and I can, of course, go ahead. I think I've got a speed key. I do. There's a down. Whoa, okay, so that seems a little bit busted. So I think I've still got some broken code here, because if I remember correctly, there should only be one exit other than the one you came in. So there'll only be 2 exits from any room, but we're clearly adding a door to every room. So basically that's just not at all right in terms of the generation code.
You know what? I saw that exact same bug before, and it turns out I actually must have had 2 bugs then, because I realized that when he's assigning, where is it? It's in here, isn't it? Tile, yeah, over here. Tile chunk Z. He assigns it to the abs tile Z, and I erroneously did the shift on the tile Z, but that's just that was just wrong. He just assigns it to the tile Z without doing the shift, because we're really only on 2 planes, and I don't really honestly understand the consequence of. I guess just because it's you're either 1 or 2, we're either on the bottom floor or the top floor, you know, whereas X and Y we're going way out. So yeah. But anyway, if I go in here and, well, I guess I should make sure. Yeah, so there must have been another bug that explained why I was seeing a doorway. Oh, I meant to change that back. I think I left that in. Yeah, let's get rid of that. So we actually get some staircases, quote unquote. So I was seeing this bug that he's seeing, which is that he's not supposed to have these, he's not supposed to have both a staircase and doors going in and out of every room. But I didn't see that he had this bug before, and so I was tearing my hair out like, why in the hell is this not happening for his code, but it's happening for mine? It looks like I did everything right. So I was not alone the whole time. Well, let's make sure that we can actually go up those staircases now. And it looks like it worked, and we still do have the same bug that he just identified. And did that work? Oh god. I have gone straight into hell, apparently. Well, hopefully we'll fix that here in a minute.
So let's take a look at the generation code, because I think the generation code is just plain busted. And we'll take a look at what's going on there. So let's see here. What we have...
Happy coding in Odin. Happy coding in Odin, Galactic.
Okay, so I see what's going on. Yeah, this is busted. So basically, the way we were doing things before is we basically said, okay, we have a door up and we have a door down. We pick a random choice, and if the random choice is 2, we go ahead and we make a door up or a door down, depending on whether or not we're on the top or the bottom layer. Right? Now, what that means is, when we get to the end, when we move to the next room, if door up or door down was true or false, we want to do the opposite for the other room, because we're going to make a room below it or above it, and we want it to have the corresponding door. So we basically flip those. The problem is, when we come back through this again, the next time, Door up or door down is now set to true or false. We make that corresponding door, but then we toggle it again. So we're just going to keep on making doors ad infinitum. What we really wanted to do here is if we come into the random choice with door up or door down already equaling true or false, right? Then what we want to do is make sure that we don't make that, we want to remember whether we added a new door or not, and only if we added a new door do that thing where we keep it, otherwise we want to clear it, right? So basically we have a couple things we need to do here. First of all, if there's already a door up or door down, we don't want to add another one, right? So we want to basically say if not door up and not door down and random choice equals 2 basically, or I guess we could say, oh, we already did that, never mind. If door up and door down, okay, never mind. We already took care of that case. I'm one step ahead of myself. We already took care of that case, so we won't do that. So the only thing we have to do is remember, if we created a door up or door down, then we do the toggle. Otherwise, we don't want to do the toggle, right? Now, the other thing we could do here is when we do this toggle, if we do the door up, door down toggle, we could also just check to make sure, we could do something like this, basically. We could do if door left or door right, or door down or door up, or door top or door bottom, right? We could say something like, as long as we know that we didn't have any other door, then we know that these doors are the ones that we came through and that we need to toggle them, right? If that makes sense. Or rather, I should say the other way around. As long as we know that we had one of these other doors in our thing as well, then we know that we need to toggle them. If we didn't have another type of door, that means that we were a door up or door down, so we should come through here.
Okay, so that's the piece I was missing. See, I didn't see him have this bug, and so I was like, what the heck? His clearly is doing what it's supposed to do. Mine clearly isn't, so what he does is just, well, I guess I'll do that, and then throw that closing bracket in there, shove all that over, and then now we say, if any of these doors happened into the room, whether we had a door on any side of the room that we're generating here, then we need to create a corresponding, well, yeah. We need to create a corresponding door up and down into the, opposite Z layer, but only if door up or door down was previously true. Okay.
I don't think that's going to work though, because, yeah, I think that's still going to be, just dumb, because that's going to also hit another bad case. So I don't even know why.
Never mind. I don't know. I thought I had worked that all out in my head, but then he's just backing it off.
I was thinking doing that. That's dumb. Let's just leave it at basically doing the if here, where we're only going to do this toggle. Basically, I'm trying to think of what the easiest way to do this here is. I guess we just want to basically say if created vertical, if created Z door, right? If we created a Z door, then we want to do that. Otherwise, we want to do the false. And I think we want to assert here that we only have the two cases, if that makes sense, right? And in fact, if we know we created a Z door, then we really know, I guess, that these are just toggles. We know that whatever it was, it's just a toggle, right? So we're just gonna go ahead and toggle these. There we go. I like that better. So basically, we're gonna say if we created one of those two Z doors on this particular
I can make sense of that. That certainly makes things look neater, but I still did not track it. And I'm not compelled to really re-watch this or look at this code over and over again, because this is mostly, we're setting this up to have a good understanding of like the debugging aspect of what's going to happen when we start making changes. We want to see how that affects the navigation of the world. It'll make it really easy to see if something has gone really wrong with some other aspect of the rendering code or something like this, because then you can see when the room hasn't generated properly. We'll be able to tell right away just by having these kind of different aspects of navigation covered in this test code, and I think that's what he was talking about earlier, where it's like it's just kind of throwaway code so that we can see the effects that our changes are having as we make them. Yeah, so we just invert these values, but we need to define created Z door. I want to make sure that I didn't miss anything there.
So basically, we're going to say if we created one of those two Z doors on this particular, if we created one of the Z doors on this particular one, then we know that the next one has to have the inverse doors of that. But if we didn't create a Z door, then there shouldn't be a door. There shouldn't be any Z doors on the next one at all. It should only be corresponding doors. So I think that's a little bit easier. So I'm just going to say created Z door like that is false, and then I'll basically say, well, actually, you know what? I can do it. Yeah, no, I have to do it this way. So basically in here, we'll basically say created Z door will equal true right there. And then when we do it, that should do the toggle or the clear. And I hope that will be a relatively clear way of avoiding that problem. All right, so if we look at here, now I go up, let's see, we should not have a Z door, and that's true. And we should only have another Z door once we get to a dead end, basically. Here we are at the dead end, we go down a level.
And so, wait, where did he turn this true? Where did he set created Z door to be
that
true?
Will be a relatively clear way of avoiding that problem. They created Z door will equal true right there.
Okay, yeah. So if we get into here, that means that on this room, we're going to create a door. So this has to be true. It's just what's left to be determined is whether it's a door going up into the next Z layer or back down into the initial one. Because we only have 2 Z layers to even go into. And so now, once I do that, so it's just coincidence that his looked right because, you know, he started off in a room with only a staircase, but it's once you go after that point. See now, well, actually that didn't work. It did not bring me back correctly, so I probably have some other issue here. Yeah. So something else is wrong. I don't know if he has the same bug or not. We'll see.
And then when we do it, that should do the toggle or the clear. And I hope that will be a relatively clear way of avoiding that problem. All right, so if we look at here, now I go up, let's see, we should not have a Z door, and that's true. And we should only have another Z door once we get to a dead end, basically. Here we are at the dead end. We go down a level. There we go. We go up here. We go up again. There we go.
Yeah, so I can't go back down. That means that I did this wrong. I think it's because this needs to be a 4. I forgot to change that. Because a 4 represents a staircase going down. And yeah, now I can go back downstairs. So pretty rudimentary, but it works. Thank goodness it didn't take me 10 plus minutes to figure that one out.
So there we go. We're starting to get a pretty respectable tile map here, people. I mean, this is basically, this is dungeon-esque. I'm feeling a little dungeony here. I could see being in a dungeon at this point in time in my life. That's something that I feel like a lot of people need to leave and find themselves in Europe and so on. Right now, we're finding ourselves in a little tile map dungeon, right? And there's nothing in the dungeon, and there's no loot to be had, so I'm not sure why we're in the dungeon. But I guess the reason that we're here is to program all that loot and make there be a reason to walk around these. But hey, it's pretty pleasant already. So there we go. All right, so we basically now know roughly an API that works okay for creating a tile map. And that gives us a good starting point. So I would say that we have sort of succeeded in sort of our goal of getting a first pass design by experimenting. Like, this is a reasonable tile map API, and if we wanted to go start implementing good sparse storage for it or other things like that, we could and know that it would be somewhat usable. Now, that doesn't mean it's perfect, and we're probably, as we get a little further along, going to find we need to revise it, but that's okay. We've kind of done the exploration that we need to be a little bit comfortable in the sorts of things that happen here, and I'm okay with that. Now, I'm looking at this and says, should these be from the center of a tile? I believe we already did that, so I can get rid of that. And for now, I guess we'll kind of just leave this way. The tile rel X and tile...
I am not sure if I made that change. Map position. Let me take a look at you. Yep. Didn't catch that. Just collapse that down. Saw some new chats here. Hey, Nutella. Galactic asks, have I made many games before? No. I've toyed around with the Bevy engine using Rust just a tiny bit, and I've toyed around with Unreal, but I've certainly never, had a game design idea that I was excited enough about and felt confident enough about how to go about implementing it to go and start doing it. I've never been at that place, and so that's kind of why I'm doing this stream, right, is to get competent at games programming so that if I have an idea, I can just go and chase it and do that thing. And it's a long process. It's a long ways to go, but mostly in my professional, career, whatever, I'm a web programmer and a data engineer. My official title is Data Engineer 3. And the joke I always make is that I'm a data engineer the 3rd. I'll provide you with a bonkers story concept when you get around to making a full video game, says Nutella. Well, I'm actually really hoping that that'll be a really fun part of the stream once we get that far, is that, people in the chat can go and encourage me to be creative in different ways, in ways that I might not even ever imagine on my own. And I think that'll be kind of a fun creative experience, is kind of using the chat's ideas to inform, just chasing different ideas with implementing gameplay and things like that. So, we'll see. We're not there yet. We won't get there anytime soon. Nice one. Some people think they can't do things. Great to see you get at it. Yeah, I mean, I've just always known intuitively that it's a very tough thing to get into, and it requires a lot of discipline and hard work to get to that point where you can actually go and implement an idea that you have. And even once you know how to get there, it's still a lot of work. Even once you have all the skills, you know how to, implement all the rendering code and implement all of like the gameplay mechanics and all these things. It's not easy even once you get to that point. So it's not, but part of the reward is just doing it for its own sake, right? And having fun, because programming is fun, or at least it is for me. Let's keep going.
Well, I guess we'll call this offset X and offset Y. I don't know. And say, note, Casey, these are the offsets from the tile center. And then I will go ahead and change all of those. So tile rel will become offset.
Okay, I didn't know he was about to do that, but I'm pretty sure, did I make that in the right place? Did I change the right tile rel? Because we have rel tile and we have tile rel. Yeah, that's in the tile map position, but then we still have rel tile X and Y in the tile chunk position. But anyway, we'll go ahead and chase all of these things down. If I can get out of my tile file. Where I think I had some errors. Yeah, right around here. So this is going to be offset. In fact, I wonder if I can just do this now. Tile rel. Do I have that right? We're getting rid of tile rel, not rel tile. So if I just do that, that should get me to where I want to go. We still have some hangovers in the tile file. Oh no. Yeah. Did not want to do that here. But we do want to do that here. Is that it? Yep. Looks good.
And then I will go ahead and change all of those. So tile rel will become offset. For now, that's my official verdict. So there we go. There we go. And now, and I think that's pretty reasonable. I'm okay with that. Yeah. So at this point, like I was saying before, what I kind of wanted to do is I was thinking about what's the next thing that we're going to want to do. And like I said, we were probably going to want to start dealing with things like player motion and collision and that sort of stuff, and sort of animation and all that sort of thing, because once we have a tile map to move around, there's really two things we can do. We can start trying to figure out how to draw the tile map with better graphics, but we also have to figure out how to make the game kind of playable and replace the player movement code with real movement code and get some monsters in there, stuff like that, right? We need both of those things, right? If you think about the next sort of things that we're going to do. And so I feel like no matter which of those we pick, whether we want to do player movement code and stuff like that and collision detection, or whether we want to do better tile maps, we're going to have to start dealing with putting some graphics on the screen that are at least reasonable placeholders for what might actually be on the screen when the game actually ships. And so that's why I was thinking the next thing we kind of need to do is start loading bitmaps, if that makes sense. So that's what I'd like to do for today. Maybe our goal for today is just going to sort of be to put a bitmap up on the screen, nothing particularly fancy, but just get a bitmap up on the screen from a file so that we can sort of pull art in as we that we can start using for our prototyping purposes from here on out. Hopefully everyone's okay with that as sort of a decision point, but let's go ahead and take a look at that. Basically what we're going to do is we're going to try and load one of these bitmap files, like I said at the beginning of the stream, which is where I need a little Handmade shortcut there. So basically what we need to do is we need to go to Handmade, and I need to do like this. This needs to be pinned. There we go, Handmade. So in the data directory inside test, right, we've got some various things here. And test background is probably a good example of something we should probably try to load. It's basically just some trees, some mushrooms, and some grass, right? It's just like a background image, right? And if we take a look at the size of this background image, right, if I go into details here, you can see that it's 1024 by 576, right? So if I go in here and take a look at our code inside Win32, when we opened up basically our window, right, when we said how big we wanted things to be, if you remember correctly, I kind of was saying, well, for our renderer, we'll make it a little smaller. And so there was some geometry that went on here, and I'll put a note in so that people can remember. Basically, 1920 by 1080 is currently like a standard HD resolution for a game nowadays, right? you know, if you're trying to run a game in HD, typically 1080p is a good standard. This is 1080p display mode, right? This is the resolution on a 1080p display. And so, you know, if that was sort of what we were targeting for Handmade Hero, I was saying, well, that's with the GPU. We'll be doing that. We'll probably try to do that with the GPU. But if we don't have a GPU, so for our own renderer, because we will be much slower than a GPU, obviously, what I want to do is basically say, okay, reduce that by half, right? And if we take a look, let's see if I can use the quick calc thing we discovered. Let's see, 1920 divided by 2. You can kind of see that basically if we divide both values by 2, we get this 960 by 540. So basically, half of that is 1960 by 540. So I was basically saying, let's run at half resolution, because then it'll be easy for us to just imagine, well, okay, everything will just be twice as dense pixel-wise. It'll just look much nicer when we go up to doing GPUs. But basically, our screen aspect ratio and everything.
Thank you, Chelsea, for letting me know that I was muted. All I was saying there is that I wanted to add in this note here. And I was just kind of, I don't know how I did that. I could have sworn that I consciously unmuted myself. You can just tell where my brain is. I don't like streaming this late in the day, specifically for this reason. It's just because my brain just stops doing what it needs to do to keep me on a good, even flow. I would prefer to try and stream closer to my lunch hour so that I'm still at least a little bit fresh. But yeah, all I was saying is that for this stuff here, it's not one-to-one. What I did say was that his code that where he's throwing these notes on is this resize div section call, where he takes the back buffer, or the frame buffer, I guess, which gets fed to the game to do the rendering to, and he resizes it to 960 by 540, and that's just kind of like the development resolution that he's using it on. And it's not one-to-one because I'm using SDL, and I think that this is like the equivalent. It's been a while since I've looked at this code, so I'm not totally sure, but basically there's the idea of like, what are the window dimensions, but then what are the dimensions of the texture that we're rendering inside of the window, and we want it to be this, I think, but then the actual window dimension, if I can find where that is over here. And what did we set that to? When we create the window, don't we set that? Yeah, to 1280 by 720. So I don't have it set to 1920 by 1080. I have it set to 1280 by 720 just because that's 1920 by 1080 would take up, the window would be massive on my monitor. I wouldn't be able to see my editor. So anyway, all of that aside.
Else will be basically the same. It'll be nice and easy. But what you'll notice is the details here are a little bit weird. Like 1024 by 576 doesn't really make much sense when you think about the fact that our screen is 960 by 540, so why did I make a bitmap that was that size? The reason that I made a bitmap that size is because, at least in GPU land, a lot of times you want your textures to be a power of 2 in size. For reasons that we can talk about later on. Basically, when we get down to GPU things, we'll talk about that a little bit more. But for right now, we'll simply say that power of 2 textures tend to be a very handy thing to be able to have on GPU side. So thinking about powers of 2 and looking at 1920 by 1080, the first thing that you might say is, well, 1920 by 1080 is a pretty inconvenient number in terms of a power of 2 if you wanted to round it. 1920 is pretty easy to fix. 2048 is a power of 2 that's very close to that. And so if you think about it, 2048 minus 1920, right? Oops, that's no good. Let's do a quick calc here. So 2048 minus 1920 is only 128 pixels difference, right? So you're only losing 128 pixel band if you went up to 2048. On the other hand, the closest power of 2, and again, it's not really the closest power of 2, it's the next power of 2 up, right? Because you can't have less than that. I need to fill the whole screen. So if I wanted to do 1080 as a power of 2, I have a problem, because basically 1024 is too small. That's the closest power of 2, right? But 2048 is massively away, which is the next power of 2 up from that. So if I do a quick count there of 2048 minus 1080, I'm wasting 968 pixels, which doesn't really make very much sense, right? That is just not very economical at all. And there's, even with screen shake, there's no chance you're ever going to use 968. So you would never make a bleed. You would never overdraw by that many pixels. It's crazy. You're just throwing away good memory at that point. So what I was thinking was basically,
all I'm trying to do is be cognizant, again, of the fact that Casey is constantly drinking into the microphone, and I don't want to do the same thing. So we've just got double gulps on stream, all stream long.
What's the next power of 2 you could basically use that would be sort of 1024 plus another band to store the bottom of the image? Well, basically, if you think of what it would take to get past 1080 at that point, you could, if you wanted to, add 64 to it, right? You could have one power of 2 texture that was 1024, one power of 2 that's 64, and basically what I'm talking about, just so that you can see it, is I've got, you know, oops, that's one heck of a rectangle there, Casey. So if I have 1920 by 1080, and I want to figure out how to fit this into a power of 2 thing, basically what I'm saying is, well, okay, 2048, if you add 128 pixels here, then 2048 really isn't too much of a wastage there, especially when you consider the fact that, you know, if you had a bitmap that was drawn that was meant to fill the whole screen, and you want to be able to do a little bit of screen shake or something like that, there's going to be a little bit of bleed, right? So 64 pixels on either side is not too much to think about in terms of bleed, right? 64 here and 64 here is not too much. So 1920 plus 64 ends up getting us to 2048, which would be roughly the size of, would be a nice power of 2 size that we could use with GPUs, right? But the problem is the next power of 2 that we would have to do 1080, we don't want 2048 for that dimension because it would be way too large. We'd be wasting a ton of space. So we only have 1024. Now 1024 is going to cut off a little bit too soon, right? It's going to cut off. Where did I do the calculation? I don't know. I thought I did it. But...
This is something I'm gonna have to come back to and pay much closer attention to in detail, because now all these details are different, because we have like 1440p and like, what is it, like a proper 4K resolution is like 2160p or something like that. So I have no idea what the ramifications are there with respect to doing, you know, rendering and how we want to specify the size of the buffer that we're writing to. And I know that the like art style of the game can even have an impact on these sorts of things, right? Like I was just reading today, somebody was asking a question about what's the right way to handle resolution scaling for like a pixel art game, and it matters. It depends.
I guess I didn't do it. So if we do a 1024, 1080 minus 1024 is 56, right? So we have to store 56 more pixels, which means that we could use a 64 wide texture. We could stop at 1024 and then use a 64 wide right here, another band. And we could basically store screen size things in 2 chunks. One chunk that looks like this and one chunk that looks like that, right? But now we've got another problem. If we're saying that we want some screen shake, and we want like 64 is what we're saying might be a reasonable number for screen shake, or maybe 32, I don't know how much we're basically saying. With our 64, the actual number that this ends up being, if I go ahead and do the quick calc on that, right? If I do 1024 plus 64, I'm only at 1088, which means I only have 4 pixels on either side, which isn't very much for screen shake. So I probably want something that's going to be higher than that. And so basically when I was kind of working this math out myself and trying to think about how I wanted the source art to be done for the source bitmaps, I was saying, well, okay, if I go with so 576, right? If you go ahead and double 576, you will see that it ends up being 1152. Is that correct? Yeah. So if I minus 1024 from that, because I think this is correct. Maybe I made a mistake here. Yeah, it's 128. So basically what I was basically saying was, okay, if we use a 128 texture instead of a 64 texture, so we store it in 2 chunks as a 128 texture, then we'd have we would have a number that was more able to give us that apron at the top and the bottom, is basically what I'm saying. So if I subtract 1080 from that, I get 72, right? So if I divide that by 2, I get 36 pixels on either side. So now I have 36 pixels on top and bottom for screen shake. I have 64 on either end for screen shake, and that seemed to me like a pretty reasonable sort of breakdown of screen geometry. Now, I realize this all sounds kind of crazy, and it is a little bit crazy, but basically I was just trying to figure out, I was like, I kind of want everything to sort of fit into power of 2 sizes as much as possible. What would be the most reasonable way to sort of do the source art so that it's going to be amenable to that kind of packing? And that to me seemed like the most reasonable thing. Now that may not be the smartest, I don't know, but that was just my opinion. This is the sort of thing you don't deal with in 3D graphics, because 3D graphics work in a very different way than this because of the way you do sort of wrapping of textures around models. And that's the way I'm usually used to thinking about things. So this may be a bad decision, we'll see, but it seems like a pretty harmless one, because at the end of the day, all the source art being drawn with an apron around it, we can always get rid of the apron if we don't want it. So if we don't want that extra room for screen shake or whatever, we can always get rid of it. So I figured having it drawn with the apron was actually probably a good idea. So long story short, or TLDR at this point, basically, if you want to skip all that explanation, the reason that these are larger than the actual size that we're going to be displaying in terms of one screen's width is because of that apron that's there. So they're all a little bit larger, and they're designed to be a little bit larger for that reason. Okay, so given that fact, and now we kind of have this sort of, I'm gonna leave this ridiculousness in here for now. Right, there we go. So I basically said 1024 plus 128. I need to bind a key to quick calc. That's what I need to do. 1024 plus 1.
I guess I should go ahead and make that note for myself to come back to. Real quick. Where was that? Buffer dim. Here we go. So 1920. To 2048. 2048 minus 1920 is 128 pixels. Yes, that math does add up. Arithmetic, what's up with that stuff? Minus 1080. 968. Not 868. 1024 plus 128.
128 is 1152. So basically, yeah, I should probably fill that in a little bit more densely eventually, but we'll just leave it like that for now. So basically what we want to do here is we want to load these images, knowing they're a little bit big, but we're going to basically try to load them and get them up onto the screen just so we can kind of see that things are working properly. So basically we want this draw rectangle call. We want the equivalent of this draw rectangle call, right? But
which of the vendor libraries am I using? Yes, Andrew is right. I'm using SDL. I tried doing it with Raylib, but I ran into some issues with controller input on macOS. And that could be because I'm stupid and couldn't implement the input correctly, but I tried testing it probably like a dozen or 24 times, and I could never get it to work. I don't know what other people use. I just rolled with SDL because it seems like a pretty good industry standard, and using SDL, you know, I can run my code on my Windows machine, my Mac, on Linux if I get a Linux machine at some point, which I do intend to. I just don't know when. And if you look online, there's other examples of people like porting it, you know, using like all of the actual API bindings, but you're probably not going to find that in Odin. You'd find it like in C, right? Like people writing like a C code that calls Objective-C bindings to do the platform layer on macOS. I know there's another guy who has a series about that, Theodore Bendixson on YouTube. He's another like indie guy who just kind of does all his own stuff. And so, you know, he does that, but he works with C. So, but if you want to use my SDL code for the platform layer anyway, I do have a repo. It may be in the description already of my YouTube channel. I put it in the description of every single video that, you know, YouTube exports after the live stream. So you can actually look at that if you're interested at all in using the code, the base code that I've written in SDL to then go. But it's like it starts right at day 26. So right when I started doing the stream, that code is basically the same version of the code that I use to go from day 26 of my stream on to get to where I'm at, which is, I think we're on day 36 now. And I think I have some code in there for the Raylib implementation. Actually, I don't, but at some point I'll add it. I'll probably add in a Raylib. Here I can show over here. So I have main. The main package uses SDL, and then the game is the game code, the same as Casey's Handmade code. But I want to add a main Raylib folder, and maybe even eventually implement separate platform APIs independent of SDL. But that's just not something I'm really motivated to do because writing platform code is not really the thing that gets me going, you know. But basically the idea is that I'd have like a main Win32, a main Linux and Mac OS equivalent, but I don't even know if those bindings are finished in Odin. I know they're still working on them for, you know, polishing and adding platform API specific stuff for Linux and Mac. Probably more so Mac is the one that I'm guessing is the least fleshed out, but I could be wrong about that. I haven't looked at any of this. So if you look at the docs, you'll find, you know, what's there and what isn't. But I want to have one for Raylib as well because I got pretty close to doing that, and I thought it would be fun to have like the functionality of Raylib to be able to just draw rectangles into my frame buffer using Raylib code. I thought that would have been neat, but I just didn't get that far because again, it eventually became apparent to me that I should just stick with SDL. So anyway, that's enough of that.
What we want to do with the draw rectangle call is we want to be able to, instead of just passing a solid color, we want to, instead of just having one color that the rectangle fills in on the screen, we want to be able to pass essentially you know, a bitmap's worth of data here so that the draw rectangle call can actually draw, you know, a real set of artwork to the screen inside that rectangle, right? And again, we're not going to focus too intently on this here because this is stuff that we'll be doing much more industrial strength when we start the renderer proper, but I just need to get something working here, so I'll explain it lightly and I won't belabor it too much, but we will sort of knowing that we'll sort of drill down a lot of this stuff later. So I'll try to give you enough context to understand what's going on, but at least for the rendering side of things, putting it up on the screen, I'm not going to kind of belabor it. But so anyway, right now, we basically just need to type in some code for loading a bitmap, right? And I don't know what that's going to look like, so I'm just going to go ahead and create a blank function here. I know that we have, in our platform code, right? We have our handmade platform code. We set ourselves up for success, hopefully, here, because we have this sort of debug file reading system, right, where we can call a thing that reads an entire file into memory. So what I want to do is make sure that this function takes that thing, right, whatever that is, and where did we actually put that? So that was debug platform. I don't even remember where we stuck it. So inside game memory, we've got these. When we pass the game memory, it's got these in it. So basically what's going to happen here is this guy is going to need this function, this read entire file. So basically, I'm just going to go ahead and pass that. This is the function that he's going to need. And this is obviously a debug function as well, I guess, now that I think about it, because we're not going to be probably loading bitmaps. For the final shipping version, we'll probably want to load something that's compressed at least. Bitmaps are really compressed, or if they are compressed, they're not compressed very well. So what we're going to do here is we're going to have this read entire file. We're going to call it, and presumably we're going to need a file name, I guess, as well, that we're going to have to call, that we're going to have to pass a read entire file so we know which file to read. So basically, we are going to do at least that much to read this file. So what we need to do there.
So I don't know exactly how I want this to look, but I think I'm just going to cheat and use Odin's built-in core, what is it, BMP image, BMP package to load in the BMPs, because for one, I didn't even implement in my platform layer this debug, load or read entire file function. I didn't bother doing any of that. I just used Odin's OS package, and that was good enough for me. So I'm guessing, I don't know what details will really be unique about the way that he's going to do it, implementing it by hand versus just using this package, but I just want to make life a little bit easier on myself. We'll still pass in a file name, and we will say it's a string, and then call, on the BMP package, load from file. All right, and then so this gives us some options, and we can use a different allocator. And this is where we could get dicey, having used our own virtual arena or made our own virtual arena and setting it to be the context allocator. Some part of me is wondering if I shouldn't explicitly use that allocator only when we mean to, because this is going to, well, maybe we're just going to put this into the game state. I think that's what we do, and in that case, I think it's probably fine, especially if we do this before setting up the world arena. But it's giving me some things to think about. But for now, I think it'll literally just be like this, and then I'm not even sure what this call looks like. But it returns the image, a pointer to it anyway, and an error. So if we go if BMP hey, buddy. You're not supposed to be in here. I know, you want to show me Winnie. I'll play with you later, buddy. Go to Mom. Yeah, we'll play with Winnie later. Ugh. Okay. I'm inundated by children-related things everywhere. I had to step over my bassinet for my other kid, which we keep in the office when we're not using it, out in the living room to put the baby in during dinner. Where was I? So we're going to load our BMP, and we're going to get an error, and then if that error does not equal none, oh no, this isn't going to give me an enum back. So what is that error going to look like? Image error. General image error. I mean, it is a union. I feel like I should be able to just verify that this error is not nil. I'll just do that, and I'll see if that even works. And if we can't load it, we'll just say could not load BMP. And I don't know if it'll let me do this or not. Is that a thing? Can I like print format line it? QOI format can be a good modern alternative to BMP. I'll have to make a mental note of that. If we weren't just dealing with BMPs that Casey gives us, is that a thing? So is there another package in Odin's? There is. So there's a QOI package in inside of Odin's image package. I don't know what you call a package. I guess is this a sub package? Or is image a collection? Is image like a sub-collection? Like, what is the nomenclature? I'm not totally sure. But anyway, so this isn't going to work. BMP declared but not used, that's fine. Yeah, so I just can't do this. I just want to be able to format. Well, I guess, can't we do like format? This will give me a good reason to finally uncomment out the format packages. Isn't it like tprint format, and then you could just say like this is our error message, right? Could not load BMP, and then we would say shut up, phone. I mute you. We say the file name and the error. Print out the error in the file name. That seems reasonable. Yeah. That's how we do it. I think that's how I've done it elsewhere anyway. And right, we have to say, we're not using this BMP yet, but we will. I think we'll just wind up loading it into the game state. What happened here? Oh, yeah, so I should just say image, I guess, because now we're conflicting with the BMP package name. Oh, you know what? I see. It's because I declare it here, but then it goes away, because I'm declaring it in the if. So probably the way to do this is, instead of being creative with this if statement, we'll just do that and then check the error after the fact. Do it the Golang way. And we're not calling it, but I just want to make sure that I'm still compiling. All right.
Is when we go ahead and read the file into memory. Let's see what the debug platform.
You can even implement it yourself. It's like 100 lines. That's awesome. I'll have to take a look as time permits at the QI format. Good night, Nutella. Thanks for stopping by.
Or read entire file thing takes. I don't actually know. It takes a thread context, so it's going to need that as well. And it takes the file name. So basically that's it, really. That's all there is to it. Not particularly interesting. So basically it just needs to do that. So when we read this entire file into memory, we're basically going to get a buffer, right? We're going to get the file contents. So that's going to literally move all of the bits that are in this file into a memory buffer for us to look at. So then the question is, what do those bits actually mean? Well, this is basically, for those of you who haven't done it before, here is your crash course in how to read file formats. Assuming that you don't know what the file format is, you first have to look it up on the web. And typically I do this literally by typing in something that looks like that. I type in the name of the file the extension that I want to know about. I type in file format, and I hope that somebody has actually documented what it is. I then try to look at these links to see if any of them look even remotely plausible. And I don't know if any of these do. Let's take a look here. Let's see. This looks pretty plausible. It looks like it's actually got sort of the stuff that we actually need to know here. Let's see.
So Casey's going to go on this path here of implementing his BMP loading code by hand, but this is why I just really enjoy using Odin, is because, not that we couldn't go the way he's doing it and implement it all from scratch and read in the pixels and then do whatever manipulation to the format of those pixels to get the color values that we want out of it. We can just load it using this package that's just baked into Odin's core, and then I can get the pixels out, and it's going to be just this buffer, I guess, which is a slice. That doesn't seem right. This is navigating me to the wrong place, but if I go to BMP struct, maybe, let's just go back over here and say, what is an image? It was not a BMP, it was image. So we get an image, and an image has all this stuff, and it's a bytes.buffer, which is what? Oh, it's a dynamic byte array. Interesting. Okay. Well, it's not a slice, which is what I jumped to the conclusion there was a slice incorrectly. But anyway, now I've just got all this stuff, and I can do whatever it is that I want to do with the image after I loaded it in. So
it's finding file type, file size.
Easy.
These have DM in front of them.
And I don't think I was even able to do this in Zig. I think I did do it more by hand in Zig, but at one point I'm pretty sure I had to import or add the Zig image project to my repository. I'm pretty sure. Although that could have been actually for a different little project I did in Vulkan. I'm not sure. Anyway, I'm getting off track here.
These don't. DDB, only file header. Yeah, so this looks relatively straightforward for us, I think. I don't see anything reason we can't use this. So if we look at the file organization here, basically what it shows us is the layout of these things right here. Since Windows 1.x is probably not something that anyone is using these days, I'm going to assume that the bitmap data here is in the file format that they're talking about for 2, 3, and 4, right? And so basically what they're showing me here is they're just showing me what they think is in the file. They're saying there's a file header, a bitmap header, a color palette, and bitmap data, right? Now I know that I save these files as RGBA data basically, so I know that there isn't going to be a color palette. I know that I don't have to worry about palletized colors. Like palletized colors are basically things where we store indexes into a palette instead of the actual colors, but I know we're actually storing colors. And in fact, when I was exporting it through GIMP, I actually selected that I want it to be ARGB like 888 or whatever, like basically the same format, or roughly the same format as we were using for all of our rendering. So I'm assuming that should be pretty easy to get it out of the file. All right. So basically what it says here for that version 2, which is I'm assuming what our version is like, or though maybe I guess version 3 is probably more what we're like. I don't know, Windows NT. I mean, these are going back real far. So I'm guessing that we're probably let's see here. This version has 3 additional fields. The bitmap header is 40 bytes in length and has the following format. There it goes. So yeah, I guess I don't know if this is the best resource for this because they're not really bitmap 4. They're not really saying much which one I'm kind of going to, which one I'm likely to encounter here, and yeah, and which one. Well, so let's just take a look. So rather than find another resource, I think I'm actually going to kind of go with this one just so I can show you some things. So we're going to load in the contents here, right? And then what I'm going to do is I'm just going to go ahead and, well, you know what? I'm just going to go ahead and have that sort of end here. I'm just going to do some dummy line of code I can stop on. And then I will, what is this saying? Cannot convert from debug read file to void star. What are you trying to convert to void star? Oh, right, we have a debug file read result, is what we have. Platform file read result. Where did my platform then? It's a debug read file result. There we go. So basically, this is going to be it's not really our result, it's the read result. So I'm going to go ahead and do that, and then we have our read result has the contents in it and how big it was, so that's totally fine. So now all I'm going to do is I'm going to go ahead and call this, basically in game update and render, I guess when we initialize. So when we initialize, I'm just going to call the loading function, and I know that we always run in our data directory, or that's where we're always supposed to be running anyway, so I'm just going to ask it to load. I'll load this test background.bmp, and I'm just going to look at what the data looks like. I'm just going to look at it, because I should be able to figure out pretty quickly which one of those things these are by just looking at it.
So I guess I should go ahead and do the same thing. Seems easy enough. If we go into our game memory initialization block here, and I'm pretty sure, yeah, he's just throwing this up at the top. So we call load BMP, and he's getting the test background out of there, which I'm pretty sure I have that. I guess I should make sure that I actually drop that in here, and I did. So that's good. And now if we compile, oh, I was getting ahead of myself trying to mess with that image struct there. Failed to load BMP test. You know what? Unable to read file. Well, my error message worked, so that's good. It just means that I think I passed in the wrong path. So we go back over here. Well, first of all, this is relative, and we're in the game package, so we got to go up and into our data directory, and then that should be good. Nope. So what I do wrong here? We go up, and we go into the data directory. can this not be relative? What is options here? That's not what I want. So I'm doing something wrong. Why can't I go to where I want to go? Here we go. Maybe, I mean, I don't think it's because of these forward slashes, because I'm doing something similar elsewhere. Let's just look at this again. So we're in the game package, and we go other directory. And then we go into the data directory, and then we go into the test directory, and then there's test background.bmp. So maybe what does unable to read file even mean? I was really hoping that this would just work, but of course it can never be that easy. I would think that unable to read file just means that, like, this path is somehow incorrect, you know? But yeah. Turns out Raylib had QI parser already, and it was 3 times faster than yours. But hey, the fact that you learned how to do it yourself, you know, you could always, the real learning takes place when you know, reverse engineer why Raylib's is so much faster, and then when you learn why that is the case, now you can make your own that much faster. And it's that is like where the true skill gap is, right? Like, anybody with at least a bit of cursory programming knowledge can go and do a thing by following a tutorial that, you know, parses some file format. But to get it to work quickly, and more quickly than anybody else's, like, that's where the true skill ceiling lies, is, you know, doing that optimization to get it to be that much faster. So I think I'm just going to let Casey roll with it, and then I might have to troubleshoot why passing in this path, like, what is incorrect about this path. I really don't know. Because I would have thought just passing in the file name would have been enough. Like, that error is not helpful enough to tell me whether it can actually see the file or not. I mean, I guess we could always do like OS, if I import OS over here, read entire file from file name. And if that fails, then yeah, there's something messed up with my path. This needs to return the data, and this is basically what Casey is doing. He's just reading the bytes straight out, right? I think like this. And of course, we're not using either of those. What if I just do this, sign it to nothing? Will it still fail on the load BMP call? It does. So it looks like we're reading in the file just fine. It may be something about the BMP format that is messed up, because I know that he had some trouble, and he has to do some stuff with the colors to get the BMPs, the Handmade Hero assets. So I might just have to do it this way and not be able to use the BMP package from Odin, which would be kind of sad, but yeah, maybe I can come back around to this. So let's do this. Let's just so I can be like on track with where he's at. Looks like I have a little bit more time on stream than I thought. Thank you, Chelsea. And so maybe we'll actually get to finish this. There isn't much code left. I think there's like 10 minutes, maybe 15 minutes left of code. So, and I don't think we'll write too much of it. So maybe I can get through this. And then what I'll do is comment this out, and we'll just say we have some bytes, and then this was, pretty sure this returns like an OK. This returns a bool, not an error, does it? Or maybe it does return an error. it does return like a success bool. So, and then we would say, comment this out. I do want to see if I can get this working, but it may just be that the BMP is formatted actually incorrectly, because I know he has to go and change stuff to get it to properly output. So let's see if not okay, then we do the same thing, right? And there's no error now, so we can just do that. Just leave all this content out for now. Get rid of that, and then bytes can be assigned to nothing. I have to actually initialize that, and now I think we're good. Oh, I have to comment out the use of this package. Real bummer. I was hoping that would just work, but I mean, Odin's BMP package can't do anything if the BMP is just formatted kind of wacky, right? Because I know he deals with some difficulty with that. Add argument number. Oh yes, I have to do. Man, I didn't want to have to do this. Let's back this off. I'm just gonna copy the whole thing and then get rid of that, because I don't want to have to rewrite that out. Start messing with the message here, so we don't get an error back, and that's fine, because I mean, if we can't load it, then we don't care. But this should work, and then we can move forward finally, or not. Okay, now I'm really confused, because, well, I guess we didn't check to see if it loaded okay, so never mind. Maybe I am doing something messed up here. Yeah, I would encourage you to go look at why the parser from Raylib worked 3 times as fast as yours did, because you might learn something pretty awesome when you go and peel those layers back and figure it out. And then you can apply that same method, right, potentially to any other code you write. Yeah, this is messed up. I'm just going to let Casey move forward, and then we'll see if the reason why I'm screwing this up becomes obvious to me.
So I'm going to go ahead and compile it. I need to pass that thread context. Let's see here. And I also need to pass the file function. So I need to pass the memory debug read entire file, right? I don't remember what exactly that was called. Let's see here. Debug platform read entire file. So I'm just going to call that. There we go. So when I come in here now, where is my debugger? Where is my debugger, people? There's my debugger. Okay, is this guy still on? No, he's still on the thing I used to download it. Let's get rid of that. Okay, so basically, now that I've cleaned up my screen a little bit here, when we come into the game update and render, right, I'm going to go ahead and I'm going to run through here, and I'm going to step into this function and take a look at what it returns for me when I come back through here. So basically, when I come in here and I ask it to read the entire file, first of all, I'll verify that it actually did read the entire file, because I don't actually know if it did. It looks like it did. There's the size of the file, and then I have the contents. So I'm just going to go ahead and I'm just going to look at the contents, basically as just a series of bytes. I'm just going to take a look at what it looks like. I'm going to put a comma 64 after the end of it so I can see a bunch of the bytes. And so I can see here that it starts with the BM syntax, which I believe I saw the document in here. So they were saying that it starts with a header that is BM. So here you go. So file type always for D for to H, and it says all versions of BM4 files begin with the following 40 byte header. So okay, so that's I guess what we expected. So file type, there's a file size, 2 zeros, and then an offset of where the image is, right, in the file. So let's see if that looks like it. Looks like what we think. So there is the B and the M, and then.
Okay, so while Casey was working through things on his end, I was kind of taking a look at this, and I realized it's not relative to the game package, right? It's relative to the whole directory where the executable is being run from. So I just didn't need to go up a directory. I just needed to use the current directory with the single dot there. And so now I'm wondering if, and also this should just be file name. Now I'm wondering if I can do this, right? We will see if now loading the BMP using Odin's BMP package will work. What am I doing here? Let's do that. And then we got to re-import the BMP package. And then when we go to load BMP, oh, yeah, no, okay, I can get rid of, wait, no, got confused again. Okay, here we go. This is the thing I needed to change. The actual, file path we're passing in here. And so there are some creative things you can do so that you're not having to hard code the path for every single asset. And Carl has a bunch of content. Carl Zielinski has a bunch of content around trying to make this process of loading in different sprites easy. And he also has like a sprite atlas generator thing that he's worked on that I haven't had a chance to go and pour through that code and see how he's doing it. But maybe we'll make that a fun thing to do on stream someday, is just kind of go through, because he has a whole template that comes complete with hot reloading. He's doing it a bit differently from Casey, but it's the same general idea that, you know, you have the shared game code library and then some platform code or the main program, whatever you want to call it, is going to be running that shared game code library that you can then hot reload and make changes on the fly. But he has a bunch of other stuff baked into that template as well. So anyway, if I go in here and try this again, and that's right, I have to go unimport core OS because we're not doing that read entire file proc call anymore. If I do this now, I think we're going to be good. Hopefully. We're good. Okay, sweet. I was just passing the path wrong. I should have thought a little bit harder about that before just assuming. My brain was like, I'm in the game package. I'm working on code in the game package, right? So therefore, I need to jump up out of there. Like, I totally, the wrongness of that assumption just totally flew over my head because I haven't had to think about, like, you know, this is the first time we're having to load in assets. We've been talking about tiles for like a week, and now we're actually doing something different. So I have to change my thinking a little bit.
There's the size of the file in bytes as a D word, so that's basically this right here. So is that actually accurate, would, I guess, be my next question. So let's say that we have something like this. So we have the contents. I'm going to add 2 to it there to get us to where we said we were. Yep, there we go. And then I'm going to go ahead and look at that as a uint32, right? As a uint32 pointer. There we go. So is that actually reasonable? That doesn't actually... Oh, oops, am I doing that right? No, I'm not. Let's try that again. Let's try that again, people. It's so hard to edit things in this tiny little thing. Basically, what I want you to do is I want you to make read result be a uint8 star. Okay, there, you did that. Read result contents be a uint8 star, which you did. Then I want you to add 2 to it, which I hope that you did, right? And then I want you to treat that as a uint32. I guess maybe it doesn't actually know what those are there, so maybe I have to do int unsigned and char star. Unrecognized token. What is the unrecognized token? What are you complaining about? I do not actually know. Oh, I've got one too many parentheses. Is that what you're complaining about? That is probably what you're complaining about. There we go. All right. Okay, so there I'm just telling it to look at the second thing as a uint32, and it looks like, and so by the way, just for my own sanity, I just want to make sure that it was okay for me to do this, because I'm assuming that it knows my types inside the debugger, because it should. I mean, I guess it doesn't have to, but it should. Yeah, there we go. So basically, I'm just going to look at that as a uint32, which is a D word, and there it is. That does look like the file size, so that's all good. Then we're supposed to have 2 zeros after that, so we've got 0. Let's see, that was the D word. So we've got 2 zeros, which it does look like they are, because those are both 16-bit zeros. So there's the 16-bit zeros right there. And then we've got the bitmap offset, which is where in the file it actually is. So there it is. And that looks reasonable. That'd just be a D word. That'd be 138. So I think that we are basically looking at exactly this, right? This is exactly what we are looking at. And so we could just go ahead and assume that that was all true, right? So I'm just going to go ahead and I'm going to copy this into, see if I can get back to my editor there. I'm going to say that that is basically what we are looking at the outset. We're looking at this. And so that's good. And so then the question only is what happens after that. The question now is like basically what do the rest of the things look like. Finding the file header in v2.0 or 2.x bitmaps is going to be this stuff. What is it in other ones? So it looks like the stuff that we actually care about though. Size of bitmap, 32 palette element, size, HORS resolution, colors used. So basically these things are the same. It looks like. Right?
It's crazy how dense this whole series is. I forgot about all the stuff dealing with the format that, you know, Win32 gives back to you after you load in the BMP. And I'm just over here in La La Land, like, whoops, I import my BMP package. I call BMP load from file. I have my image. Was there an oopsie? If so, I print it and I panic and I cry. Otherwise, we got an image. We're happy. We're good to go. But not that it isn't awesome to see him unpack this stuff. But I guess this is what I'm driving at here, Andrew, is that by digging deep in the way that Casey has. See, if I hadn't already done a lot of this work in Zig, I might be motivated to follow along exactly the way he's doing it. But because I have, and I kind of understand generally, even though I forgot a lot of the details, like if I needed to dive down, right, and actually deal with the, you know, parsing the file format out from whatever platform that I'm reading the data in on, I could go and do that. You know, I have the capability of doing it. And that's one thing, but then to go and optimize that stuff is like where the magic really happens, and that's where you can save and make a lot of money. You can save a corporation a lot of money by having that knowledge, and you make yourself a lot of money by being able to go and implement it.
Right. It looks like we always do that, but once we get to compression.
And I said corporation, but I mean literally just any business. Any business that has some need that can be optimized with some kind of software tool, you could be an asset to that business, right? But then, having the skill to implement the thing is one thing. Figuring out to build is the really hard part.
They may or may not be there, basically, right? They may or may not actually, it may or may not have compression or size of bitmap or the resolution or colors used, color important, that sort of stuff. But that's really the only difference. So if we assume temporarily that we're only going to be reading uncompressed, we could just look at these fields and assume that we always have them and that just read them in, right? So we can just, again, this is just debug code. We're not trying to write a file processing library. We're only ever using assets that we ourselves load. So basically, this is pretty good in terms of what we're actually looking at, in the file. So what we could do here is we could just look at it this way. We could just say, okay, here's a struct, right? This is the bitmap header or something like that, right? We could say that. This is the bitmap header, and I don't know, just here's the actual sizes of each of these things. This is a int16, uint16, right? Uint32, uint32, int32, int32, uint16, uint16, right? And we could basically just say, all right, this is the layout that we are expecting to look at, and we can say, all right, this bitmap header, I am going to go ahead and take a look at that read result contents. I'm going to take a look at that as the bitmap header, right? I'm just going to cold cast it. So assuming that read result size, right, is not equal to 0, assuming that we were able to read it, then I'm going to take a look at the header. Now we've got a problem here, right? And I guess I can probably demonstrate it as well so that you can see it. What did I call that again? Where is the read results? Where is my read results? Content size. So there we go, content size. So if I go ahead and I actually run this, we have a problem, and I've talked about it on the stream many times before, but just to solidify it for people who, again, might not be familiar with this sort of thing. If you notice, when we actually do what I just said, we'll have a problem. And so when we open this up and we look at things, you'll notice that it doesn't look like what we had hoped, right? We inspected it, and we were expecting the file size. We looked at the file size supposed to be correct. Like, what's going on here, right? Why do these look wrong? Well, the answer, of course, is because, like I said on the stream before, when we lay out a structure, basically C++ is under no obligation to actually pack that structure tightly. So when we say that there's a uint16 and then there's a uint32, it doesn't have to put those adjacent to each other, and in fact, it won't. What it does is it aligns things to a boundary that is the same as whatever their size is. So if this is 4 bytes, this is only 2 bytes, it will skip 2 bytes to put this on a 4-byte boundary, basically, because it is 4 bytes. So basically, if we want to read the memory in a nice layout here, we have to tell C to pack that structure tightly. And so what we have is kind of this really janky system. I think in certain compilers, there's better ways of doing this where you can just label the struct as tightly packed, but that is a relatively new thing.
I'm not even sure if this is totally the same thing, but like in Zig, what he's talking about, the way that you would do this is that you would specify the struct as being an extern struct. And so that way, the compiler will not mess with the layout of the struct in memory when it goes to, build the thing that then, runs all the machine code that then, says this is what that thing looks like laid out in memory. The extern, I think, will make that basically static so that the compiler won't mess with it. Extern plus align 1, that's new to me. I'm not sure about the align 1 part. So you said I would say parsing file is not interesting since it's pure. I'm not totally sure what you mean by that, but an interesting part is one which handles state. I mean, you might be surprised at how valuable just parsing some file or making your own file format can be. Extern just makes it like C, and Casey has that problem in C. Yeah, so I guess then I'm not sure I just know that I had to use extern for a similar reason then, where it was like the compiler is messing with the order, and he's talking about the order of the fields in the struct. So I'm not sure what the difference is then.
Basically, there's a thing, pragma, pack, push, and pop. It's kind of ridiculous, but I'll basically show you what it looks like. Essentially what you do, if you can take a look here, you can basically do this thing where you do pragma pack, and then you can say what the packing level is, right? So you can kind of do something where you do something like this, pragma pack 1, and then it will pack everything to be 1 byte aligned, even if it would have packed it otherwise, which is what we want to do. Now, unfortunately...
Interesting. So it could be that I got like a false positive when I used extern, and it worked the way that I think it was working, but I was just getting lucky and it wasn't breaking. Maybe that's what you're saying.
At the end of this, we'd like to set it back to whatever it was, but we don't know what it was. We don't know what the default packing was going to be, right? And we don't know whether we might be inside someone else's pack block. So basically what they do in a lot of cases, just to make things easy, is they do a pragma pack push, which basically is a thing that says push a thing on the stack, which is basically going to be, I don't know if you can see it here. Here's
U32 in Casey's case had alignment of forward and will be aligned, so you can override alignment. Yeah, like I understand alignment naively, but I guess what I was trying to say is I wouldn't know how to specify a struct as being an extern struct with an alignment, with a 1-byte alignment. Does that make sense? Hopefully it does.
Okay, here's a good example, right? Basically what you can do is you can use this push pop thing to basically tell it to just, okay, for the region that I'm in, start, it's like a stack, push this new value for packing on the stack, but then when you're done, pop it off and go back to the previous value that you're at, right? So if you do this, pragma pack push 1 and then pragma pack pop, in theory, you get a thing where just in between those, you're tightly packed, but everywhere else, you're regular packing, right? So now when we come in here and we look at the header, you can see that everything actually looks right now. Like here's the actual size, right? Here's the width and height of the bitmap, and they're what we expect. Here's the bit per pixel, which is what we expect, 32, and so on. And so really all we need to do is jump to this bitmap offset and load the bitmap. That's about all we actually need to do. And so there's one other surprise waiting for us with bitmaps that we'll see. I don't know if we'll have time to blip this today. Probably not if it's the 5-minute wording. But basically, we now know what the header is, so we know what the width and height are, and we now know exactly where the data is. So we also know that basically our pixels, right, are going to be read result contents. We know that they are going to be wherever the contents are plus the bitmap offset that we got in the header. But of course, we don't know what that bitmap offset is relative to. Is it relative to the start of the file or what? So I'm going to go take a look at that spec again.
So here he's getting the pixels out by jumping to the offset that the bitmap is at within the read result. And thankfully, I don't have to do that. So I guess what I would do is just, maybe if I format.printf ln this image's pixels out, and then I can make sure that I actually got the pixels. What'll that give me? Well, it would help if because I think I have that debug FPS stuff. Okay, so it did print it all out. That looked like a whole lot of bytes to me. I think we're in good shape. Extern struct with member A, U16 align 1, B, U32 align 1. Interesting. So maybe I did do that. And like you're showing here, you know, give it an alignment, a 1-byte alignment right on the member A and member B and every other member. Maybe I did do that, but maybe I didn't. And like I said, I got a false positive because I thought all I had to do was the extern struct, and then the rest of it, you know, didn't have to be explicitly stated. Interesting.
And just see if it's specific at all about what that bitmap offset actually means. So starting position of the image in bytes. I don't know if they are any more specific here. Bitmap offset, starting of the bitmap from the beginning of the file. So basically, we did the right math here. That's going to be the start of our pixels. And then we're expecting to have basically width times height pixels worth of data, I believe, because it's 32 bits per pixel, should be well aligned. I think, I don't know, basically, if I don't know if they talk in here at all about that. Image data. Uncompressed data is a series of values representing the color. Each scan line must end on a 4-byte boundary, so 1, 2, or 3 bytes of padding may follow each scan line. So the only other thing we have to worry about is basically our pixels are going to be 4-byte aligned. Since they are already 4 bytes, that should never actually be a problem for us. But if we were going to load a 24-bit one here for some reason later, then we would actually care. But that is our pixel pointer, and that is basically all we actually needed to know. Now, if we want to, we could probably do something cheesy here to test this just real quickly in the 3 minutes that I have remaining. So let's see here. So this is a UN32 star. What is the contents pointer? It's a void, yes. Okay. So there we go. I'm just going to go ahead and cast that. So what we could do here, if we wanted to, just as a test, we could go ahead and say, all right, let's return that for now as a cheesy thing to do. This is totally temporary, not at all what we actually want to do, but let's just do it for now. So I'll return result here, and then I will do result equals pixels. Okay, so when we load this into memory now,
I wonder if how he's doing this. I wonder if I could just, what does it return? A U32 pointer. So he's basically getting a multi-pointer back. I don't really know if I want to return that pixels member like as pixels or as the bytes.buffer, right? That's what it is. But maybe I should just suck it up and do that. For the time being, anyway. Because part of me just wants to return like a, you know, a U32 slice for this, but I don't really know. That was weird. Felt like a bug flew down my throat or something. Yeah, I don't know. I mean, I guess maybe could we do something like that? Get a slice to it. I don't know. Cannot assign value image.pixels of type buffer to U32 slice. I'm betting I can't just call that a buffer. I'm gonna have to import core bytes, and then we'll just say bytes.buffer for now. And then if I want to massage that a little bit, I'm running low on time, but if I want to massage that a little bit, I can do that off stream. It's really close here.
Now, we're going to have a pixel pointer. So I'll stick that temporarily down in here, which is just say pixel pointer, right? And I will go ahead and say, all right, the game state pixel pointer equals that. And now we have a pixel pointer. And now what I could do is I could basically...
So he's going to do that. He's going to modify the game state. I'm really tempted to just rename this game state. My sanity is deteriorating every time I look at it, and there's just something too generic about that. I was hoping that just by calling it state, it's inside the game package, that would be like explanatory enough for my brain to, you know, rationalize the badness of this name away, but I'm having a hard time with it. So where did he throw that on? Underneath the world and the arena. I guess I have this out of order myself with respect to where he's doing it. Not that it matters all that much, but pixel, I'm going to just call it a buffer because that's the type that it's going to be. And then we'll assign that to the game state pixel buffer. Make sure that runs. And it does.
Go ahead and say, all right, the game state pixel pointer equals that. And now we have a pixel pointer. And now what I could do is I could basically just copy our draw rectangle function, or I could even just split it to the screen. Yeah, basically what I could do is I could say, let's just copy to the screen. It will be aligned incorrectly, but let's just copy to the screen. So at the end of the frame, we'll overwrite everything we did. Basically that buffer that we're writing to, we'll just go ahead and overwrite that. So I'm basically just going to say, all right, for y equals 0, y is less than buffer height, plus plus y, and then I will do an x here, x, 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 width. And then what I'm going to do is I'm just going to straight up copy the pixels from the pixel pointer. So I'm basically going to say, all right, the game state pixel pointer, I'm going to go ahead and say I've got that, and then I've got the uint dest, and that's the buffer pixels. And I'm just going to go ahead and full on just do the dest pointer equals the source pointer. And of course, the stride won't be right, so our image will be all sheared and weird. But I just want to see if we're loading anything even close to right in the short time that we have left. So okay, I think I have to cast that if I'm not mistaken. Do I? Oh no, it's just pixels isn't a member of the buffer. So let's take a look at what that actually is. So the buffer is a memory. There we go. So memory. There we go. Oops. Signed unsigned mismatch.
Okay, I'm going to get caught up with him. I'm just watching very carefully here because if I'm going to screw up any of the code on the stream, and I already have, it's going to be this in particular. So he did it down beneath that last draw rectangle call. And so we have the source. It's going to be gamestate.pixel pointer. And the dest is going to be the frame buffer. He just calls it the buffer, but I'm calling it the frame buffer. Memory. Game state has no... Oh, yeah, I called it pixel buffer, not pixel pointer. And then for y in, 0 to the buffer's height. And we want to go up to just one underneath that. And then again in the x by the width. And so now, so the way I have to do this, right, again with slices, is that source dot, oh man, this is gonna be a bit jank here, but hopefully I can figure it out because I gotta wrap this stream up. we go into why, there we go. Go into here. Let's look at this buffer type again. So a buffer is a variable sized buffer of bytes with an IO.stream interface. So we could stream it out one row at a time, but I just don't want to do that. So can I just say, can I index into the buffer at y times, and this would be like, you know, source index, I think, y times the buffer's width plus the x, in much the same way we've done it before. Yeah, this isn't quite right, but maybe I'll call this the buffer index. I already know I'm thinking about this incorrectly, but I'm just trying to get the code out there so I can try and unpack why my understanding of it is wrong. So we have the buffer index, and we want to get into, actually no, I feel like this should just this should just work, right? Because we're just copying it all over one pixel at a time out of the pixel buffer. And I neglected to call that the frame buffer, even though I just said that out loud to myself to remind myself. I think that just works. Well, that is messed up, but that's, you know, in the right direction. You can kind of see the trees. They're all black and white for some reason. I think this is going to look a bit different than what Casey has, but yeah, we know we can at least actually get something resembling the image out, which is good. It's just I'm doing it very, very wrong. We'll see what kind of result Casey gets here, because I'm pretty sure it might just be that I'm indexing into this wrong. You know? Because I thought it was supposed to go across the entire screen and cover the whole screen. So, yeah, where did I go wrong there? Because we're just starting at the beginning, right, at y0 and x0, and then we should be going across the entire width and height of the frame buffer and drawing it all in. But it looks like we're starting in the wrong place. I don't know. I'll just let Casey go forward, and then we'll see what happens on his end.
Oh, those are integers, I guess? Okay, here we go. And let's take a look. So that is not a particularly good sign. That doesn't look particularly good to me. I don't know about you guys. We have a bunch of things that are expected problems there. I can fix.
So his looks wrong. Very wrong. I don't know if that looks just as wrong as mine, because at least his covers the entire screen the way it should.
Fix the shear, but that's that's pretty funny. So yeah, okay. We will pick that up next week, because that is not at all what we want to look at. And rather than debugging that now, because there's a couple things we have to do. So basically, we have to do the stride so that it's copying correctly without shearing. Then we have to fix the color ordering if the color ordering is wrong, and all sorts of other things like that. So I'm just going to not actually do that, because we'll just eat into the Q&A. I'd rather keep the Q&A on time. And tomorrow we can be basically how to blit that stuff onto the screen, and then we can also do our debugging of loading the bitmap in case we had bugs in that code, for example, where we were saying that the pixel pointer might have been wrong or something like that. It looks like our header is correct, so it's just whether our bitmap offset is correct or not. Okay, so that's it for now. It's time to go to the Q&A. Please prefix your questions with Q:, so I will see them. And if you could also try to keep questions to programming questions that are about today's stream or previous streams, that would be very helpful so we can stay on topic. All right.
Is our buffer width the right size to cover the entire screen? You know, that's a good point. I mean, I guess the width isn't the problem that we're seeing for the moment. What we're seeing is that the height, like the image doesn't go down far enough. But that's a good point. I was thinking about that wrong. I don't have time to go into the Q&A, and I probably, almost certainly, actually do not have time to figure out how to get... Because first of all, mine is black and white. Casey's is all blue. So that means our implementations are wrong for different reasons, and obviously the fact that I'm reading this in with Odin's BMP package and not, you know, just reading the bytes in straight out of the file. And maybe, you know, that's a good point. Maybe I should just try doing that next to see if I can get the same issue that he's having, and then it'll be easier actually to debug. So it might just wind up being easier not to use the BMP package, but I would like to understand why that's not working. You thought it was a moon texture. Yeah, I guess you could kind of, but yeah, the way that the trees are kind of overlapping each other, you could kind of think that maybe those look like craters, but they're all in the shape of little trees here, right? But his is all messed up. Yeah, it could be, excuse me, if I go look at this again, and it is, oh, so this is just bytes, but he's not, okay. I think, so I actually missed that step that he did there. He converted the memory to pixels. That could be part of my mistake for sure. And I don't think that I can just do that. Or no, yeah, he converted, okay, maybe I can do that. Yeah, so the frame buffer's memory is in U8, but we missed this step. He casts it, but I think I can just transmute this to a U32 slice. And then it's saying cannot assign value. Oh, because this is the same thing basically. So if I were to do like this and transmute, can I transmute a dynamic array? There's almost certainly no way that this works. Transsuit. I wanted transmute. What? Transmute. That actually works? Okay. Wow. All right, let's see what we get now. We crash. All right, well, that's not as good, but you know, we're on the right path. We're getting there. Happy little trees. Well, they're not so happy yet, right? Because they're being rendered improperly. BMP has RGB like BGR. Odin probably flipped them when Casey did not. Yeah, that's exactly the issue that he has, and that's why that's what he starts sussing out in the next day of coding, which we'll get to tomorrow. But I have to go. I will figure this out off stream because we are really close, and obviously Casey still has some ways to go. But this much was definitely true, that I was doing yeah, so that is a big part of the problem, is that we're iterating over the height and width of the buffer in pixels, but then we're assigning one byte at a time. And now if we back all this change I made out, yeah, this makes perfect sense now. So if I do this, I go back, we rerun it to the point where we're working again. We're only covering 1/4 of this the buffer. You see that? And we're doing that because we're only assigning one. We're going in like basically 1/4 to the as far into the buffer as we should, because we're going in bytes rather than in pixels. So I guess I can just leave my to do in here. Assign. Let's see. Write to the frame buffer in pixels, not bytes. I think that captures that closely enough. So I'll be back tomorrow, and I'll probably have a solution for this. First of all, the big thing here, and I mentioned this before, is that pixel buffer should not be a byte stop buffer. It almost certainly should be a slice. And my son is breaking into the office, so I gotta go. Have a good rest of your night, and I will see you guys tomorrow.